Welcome everyone. For those of you who haven't met me before, so I'm Matt and I'm the lead data scientist here at Data Technology. So what we wanted to do was, yes, show the demonstration of the Wine app that we've got for you, but also to talk to you about some of the things that we've learned across the world of machine learning in business over the last few years and how we've actually taken this into forming our prediction as a service offering. So machine learning is probably a term that many of you have been hearing about for a few years now, and it gets thrown around a lot. And the idea of artificial intelligence working alongside us in business is quite an exciting one. But many of you who are actually working in these driving seats are probably asking the question of how can machine learning really help us? And the short answer is probably in a lot of ways. Now, I can see a lot of faces on the screen at the moment, and I know that we've got people coming from a lot of different industries. So I've put up just on the screen here just a few sample use cases that we can use for different industries, but also just the cross-sector ones, which are actually often the most bang for your buck. Now, with the cross-sector ones that we're talking about here, churn prediction and demand forecasting is probably something that everyone on this call can think we've got some relation to that. Now, churn predictions is where we're predicting the likelihood of losing customers, and that way we can actually proactively reach out to them. And we can actually analyze these models as well to understand not only who's likely to leave, but what are the driving factors. And this can really give us some understanding on what our services shortcomings are at the moment and how we can go forward with and best shape our goods and services. And then demand forecasting is quite an umbrella term, really. Demand forecasting can be used for balancing supply and waste. It can also be used for managing warehouses or just ensuring that the right people are working in the right places. Really, though, everything on the screen and beyond, machine learning really represents a way that we can take into account far more information to make predictions than traditional forecasting methods. And really, we can quantify all of those hunches and the finger in the air analysis that we've traditionally had to rely on when forming strategies in the past. So these are all different things that businesses are able to achieve with machine learning, and it is a space that's growing. And there's lots of different ways to build and lots of different platforms that are offering these sorts of services. And that sort of asks the question, what are we doing differently? So prediction as a service was really built out of our experience from working with customers and seeing a pattern of dilemmas that companies were facing while we were exploring machine learning for the first time. And that dilemma is simply that whilst machine learning has great potential business value to them, getting started is a really daunting thing. Traditionally, if you wanted to start doing machine learning, you'd have to build up data science teams, you'd have to buy expensive platforms, and that was the cost of entry just for giving it a go. And all of that would have to be done before you've even proved that you've got any benefit out of it. So in many cases, they just wouldn't. So we built out prediction as a service, and really we wanted to create a new way for companies to take their first steps into machine learning. And the fundamental goal that drove us with this development was just lowering that barrier to entry. Prediction as a service is essentially a framework, and the framework is split into two overall components. So we have our feasibility studies, and we also have our production development and management cycles. So when we begin with the feasibility studies, this is where we're taking a use case and a client's data, and we're seeing if there's any predictive power within that data. So we do an exploration of the data and we actually train and analyze real machine learning models. And we just qualify whether we can actually create accurate predictions with the data that they have. And then we assess where the data is actually stored and how and if we can build these pipelines, which would then feed into a production model in an automated fashion. And really the outcome that we're aiming for with these feasibility studies is real clarity into the sort of performance that you can get out of a use case and a roadmap for how we could go from this proof of concept into an actual production model. And this is where we leave it to the client and they decide how they want to proceed. So if the results don't really show what they were looking for, then we can leave it there no harm done. And then part of the analysis we've done will actually be able to give them insights into the other kinds of data that they can start collecting, so that down the road, forming their data strategy, they've got a better chance of being able to tackle these sorts of machine learning use cases in the future. But if people are happy with the results and they can really see what the benefit to the business would be, then data technology, we can develop the models and manage them for you. And then the client just has to worry about making the predictions from the model without the need for any in-house data scientists. Really, the benefits come down to the four main points that we've got up here. So the first one is provable performance. So there was a Gartner study this year, and there were surveying companies that were implementing data science, or at least trying to. And they found that 54% of data science projects make it from pilot to production, which to my mind is a very optimistic spin on saying that nearly half of all data science projects fail. And if you're going to fail and you never know what predictive power data has until you try, you want to fail cheap, and you don't want to employ a data science team of 10 people, buy a big platform to then realize that you aren't in the right position to be able to do this sort of thing. We don't need any in-house data science. So a lot of companies are struggling with the talent shortfall at the moment in data science. And even if you're managing to employ these people, the turnaround from recruitment to building up teams is a long and harrowing process. And again, coming back to that provable performance, we don't know if that's ever going to lead you to the results that you want. It's scalable, so we only look at a use case by use case basis. There's no extra chaff. You're not buying a bloated system just for the sake of a use case. We're just delivering that particular machine learning model. And all of these things really lead to fast time to value. Now, that's obviously illustrating the point of how prediction as a service can lower the barrier to entry in building machine learning models. But this is all a bit abstract, really, and we haven't seen what does a machine learning model look like and how can it actually be used in a business. So the next thing we're going to go on to is our application. Now, what we've done here is we've actually taken a machine learning model that we've built on our platform, and we've integrated it with a SaaS Click dashboard to try and illustrate how a machine learning model could be used. So to fit the theme of the day, as Gus was alluding to earlier, we've taken a data set from a wine retailer, and what this data set consists of is the chemical compositions of different types of wines, as well as the average score out of 10 that their customers have ranked them. Now, obviously our dear friend Gus would often usually look at more traditional characteristics of wine when making a purchase, things like the terroir, the chateau's reputation, and other abstract things like, I don't know, what movement of Vivaldi's Third Symphony was playing when the grapes were being picked. But we've taken a slightly more scientific approach. So we've been looking at things like the amount of sulfates that are in wine, the volatile acidity, and the all-important alcohol content within wines as well. So if we come on to our first page, this page is all about analysing the machine learning model that we've trained. And this graph in the top left that we'll expand out now is our feature importance graph. Now, what the feature importance graph shows us is how often does our machine learning model look at a particular feature when it's trying to determine what's our customer ratings for that wine. Now, we can see right to the top, by far and away, the most important feature for this particular data set was alcohol. Now, I suspect that it says a lot more about the particular customers who were buying and reviewing this wine than the actual driving factors of good wine itself. But again, as playing the role of a wine retailer, this is what we're looking for. We're looking for what's going to get us the best reviews from our customers. Now, beyond just looking at the feature importance, we can also look at the feature effects. Now, this graph at the bottom here actually gives us some insights into the differences between what makes up a good white and a good red wine. And we see some interesting differences, like, for example, citric acid. When we've got slightly more citric acid in a white wine, that tends to lead to higher customer ratings for these groups of wines. Whereas with red wines, when we have higher citric acid, this actually has the opposite effect, and that actually causes customers to like our wines just a little bit less. And we can go beyond just looking at these things overall, and we can actually start looking at how features start to actually interact with each other. So on the right hand side here, we've got plots of how for each individual wine, our top 3 features affected the wine's quality scores. So right here in the middle, we've got our volatile acidity. And if I pop open this graph here, what we can see is that in general, when the volatile acidity of a wine increases, we start to see lower customer ratings, and that's what the model is predicting. But actually, when we come up here again and we start looking at higher proof wines, and we start looking at our 12 to 15% wines, and we look at that graph again, we can see a much flatter correlation between how much volatile acidity is in the wine and the kind of effect it has on the ratings. And I think this goes back to the point we were making earlier, that the customers we have who are just after something that's really, really strong and is going to give them the desired effect probably aren't too worried about the profile anyway. So
I was going to say, Matt, as well, just for everyone's benefit, just to kind of make it a bit real, volatile acidity sounds like a very scientific word. It just basically typically relates to smell. So this is like the volatile gases that wine gives off. So obviously, if you have a higher volatile acidity, you're going to get sort of more gases, more smell in general terms.
Yeah, that's right. And I think it's a bit more of like a vinegary sort of smell, isn't it?
So I hope not, but maybe.
So that's
if it has a vinegar smell, it's off, Matt.
Yeah, well, I mean, if it's coming, you know, the higher it goes up, the worse it's getting rated. But so that's really how we're trying to look at the model's parameters itself. And this is how we could start gleaming some more complex insights, which would be far more time consuming through sort of traditional data analysis methods. But what we actually haven't done yet is make any predictions with a model. So let's go ahead and do that. So on this screen here, what we have is our wine prediction comparison chart. And if you can put yourself in the shoes of this wine retailer goes to lots of different vineyards and tries to source different wines. And each vineyard that they speak to, they get these big bitter spiel about where the grapes are grown and you know, the history of the chateau and all these sorts of things. But actually, something that they can do is, well, by taking a sample of these wines, they can actually find out the chemical compositions of them. And then we can start looking at what actually makes up these wines and how that is affecting our customer ratings that we're getting back. So at the moment, we've got the same wine entered into both Barrel A and Barrel B. So what I'm going to do next is I'm going to start entering a second bottle of wine into Barrel B's parameters, and we'll see how that changes the prediction. So what's actually happening here is, while I'm typing in these different values, all of these parameters are then being sent to the machine learning deployment that we have, and it's just instantly sending back and updating our predicted value. And we can see that as we're entering in the profile for Barrel B, we can now clearly see that Barrel B is expected to be getting nearly 1.5 times more stars out of 10 than Barrel A. And this shows us how we can actually start using machine learning to make more informed decisions. And I think what you can also agree on when we're saying this is it's really easy, once a model's deployed, for a non-data scientist to be able to interact with these sorts of things. And that's one of the 2 key takeaways that we really want you to get from this. With prediction as a service, we take away the complexity of building, deploying and managing machine learning models. And actually, once you've got these models deployed, you don't need teams of data scientists within your company to make use of them. And actually, it's other people with business expertise, such as your sommeliers and your wine purchasers in this case, that can actually get the most value out of using this. So that really concludes our little dive into wine prediction and just a bit about machine learning and what we've been doing over the last year in the space. So thank you very much for listening.